So let's begin with myopic problem. A person who has myopic, if not short-sightedness, if not nearsightedness, he or she will be able to see near objects clearly, but unable to see distant object clearly. So generally the far point can be less than few meters away for a myopic person. That is, starting from around 25 centimeter to few meters away, maybe 2 meters away, the person is able to see things clearly. After that, it is blurry. Again, this is not fixed. It depends on the problem, the amount of problem. So this far point is not infinity for a person who is myopic. It is way less than infinity, even few meters away. So what exactly is the problem? So anything behind this certain far point for this myopic person, like say this point, the incident ray, right, will converge just before the retina, something like this. So it's not able to converge on the retina, but it will converge before the retina. It misses by few centimeters or few millimeters. So that's the issue. So what causes this? Elongation of the eyeball. So if this is your normal eyeball, the person might end up with something like this, a bit elongated, right? So that will cause this issue. Then second one is far point can be excessive curvature of the cornea. So the first thing is, where is cornea? This is your cornea. So what happens to this? Instead of being like this, it might end up something like this. So because of this as well, the person will suffer with myopic problem. So how do you correct it? With the help of concave lens with suitable focal length. So the lens, how does it help? It refracts the ray away from the principal axis before they enter the eye, allowing them to focus on the retina, not allowing them, allowing them. So all this I'll explain the second point. First, we'll see the experiment wherein I'll simulate a scenario wherein the lens is not able to focus onto the retina, and with the help of concave lens, it will correct it. Right? So let's have a look at that experimental video. So first thing is, you have your retina and the lens. So the screen simulates the retina and the lens is the lens. As you can see, it can converge front of the retina, something like this. But the retina in actuality is at the back. To help correct this, we'll make use of, you can see over there I have a concave, and we have a sharp image at the back. So can you see that it's a concave, right? And you have a sharp image on the screen. So yes, it's kind of dull. Again, this is the setup which makes it, that's the cause of this dullness. But yeah, a person with glasses will not see dull images, not to this extent at least. Okay. Yeah, so I hope you guys observed this. The lens was able to converge the light before the retina, and to correct this we used concave lens. Okay, so next we will understand all of this with the help of ray diagram. So this is the setup for your ray diagram. The first one deals with the farthest a myopic person can see. So this is, say, the nearest, and the farthest may be somewhere over there. Again, I'm just assuming this to be the farthest. So what happens? Any object over here, what will happen? It will go through this and through the focus, and all of this will happen, and the person is able to see a clear-cut image. Okay, so this is what happens. But if a person without the glasses, myopic person that is, if he or she is getting a ray which is behind your farthest point, so remember this is the far point, and this is called the near point. I already defined it, so you guys have to check your notes if you have written. So somewhere over here I'll assume it to be near point. This is the far point for this myopic person. So anything behind that, something like this, what will happen? Without glasses, it will converge in front of the retina and the person will not be able to see. Now, I want to correct it. How do you go about? The correction happens with the help of concave lens. So this is your concave lens. Concave. So what will happen? So this is the far point, and I have light coming from behind this. So this lens will, in general, what does this lens do? It will diverge. So the diverging thing will happen, and this lens will converge onto the retina. So this divergence, how does it help? Well, if I happen to follow this light, this light path, if I call this as point A and I call this as B, if I follow AB, I'll be able to trace it to something like this. Again, I'm tracing it. By default, concave produces a virtual erect image which is same side as that of the object. So in this case, it's over there. This point is, we'll call this as O dash, is within the range of the person being able to see. See, it's within the farthest the person can see and the nearest the person can see. So it's within that range. So anything within that range the person can see. That's the whole idea, right? So I'll explain it in a different way so that you guys will understand it a bit easily. See, when we go and talk to old people, right? When we go and meet anyone old, and if their hearing or eyesight is kind of less, what do? We go very near them and talk loud, and also go near them so that they can see our face. So why do we do that? Because we are getting the object, in this case the face, to a point wherein the person can see. So a person who is far away, the old person is not able to see them. But the same person goes near them, they are able to see, because we are getting in a range where the person can see. That's the whole idea, right? So this lens is doing the same. An object which is far away, so object is far away, but the image produced by the concave lens is near. So this particular lens is able to converge onto the retina. This is the whole idea. Understood? Okay, so this is how it works. So this is the image produced by the concave. So this is the new object, image by concave. This is the new object for eye. So the eye is able to see because it's within the range of your farthest and nearest point. Right, it's within that range. So end of it, he or she is able to see the image or the new object. This is the whole idea. Okay, I think I explained everything. The lens refracts the ray away from the principal axis. So you can see, so this is getting refracted away from the principal axis. That is moving, it's diverging away from the principal axis. So allowing them to focus onto the retina. So this allows the lens to focus things onto the retina. I hope it made sense. It's quite simple itself. So now pause and write pretty much everything. Nothing should be missed. If someone wants to make a running note, you can do this. Now you're going and talk to someone elderly, right? Okay, one last time. Have a look at the experiment and try to understand what we learned. Understand and recall what we learned.